secondary goals, some side intentions, and we're balancing computer automation with simplicity and with a user kind of controlling the main loop. The calculation and comparison is something that a human could do, but we want automated because we don't want to have to think about it. So that calculation, this comparison that the computer is going to be doing between the two numbers, that's all going to happen without our involvement. It's sort of strange background process that we can just trust that as long as the program was written correctly and no weird glitches happen, that it's something that happens for us. And theoretically, if you have enough things that are happening for you, you kind of create a situation that you're not fully participating in. It's not you doing it, but it's happening for you, with you, because of you. It's a strange thing to think about, this idea of automation, what it really means. But what we do know is that it can be useful. Having things happen for you allows your conscious activity to be focused somewhere else, on some task that hasn't been automated, that can't currently be automated, that isn't worth automating, that you don't want to automate because you want to focus on it. This is our first little delve into truly automating something for ourselves and seeing the usefulness of it. What's interesting is that when you compare two things with the intention of seeing if they're the same or different, just that word, same or different, that's information. And if we want our computer to hold that information, then we need to create a way for it to hold that information. And what's interesting here, again, we're creating a way to hold information. That's what I mentioned earlier that we're repeating, but we're doing it about something different now. Instead of about a number, it's about a comparison. And this is going to, when we get into programming, allow us to see that there's different types of containers that hold different type of information. And that is going to be another common theme. There's a lot of nuanced ways to read into this. Doing a similar action multiple times, and sometimes that similar action is exactly the same, and sometimes it's just a little bit different. Let's not read too much into it though and move on, and we'll come back. We'll circle back around quite a few times and build up on that idea. This next step, generate comparison information. As I mentioned, whenever you compare things, you're generating information, so that's what we're doing here. And we're using the two contained numbers, so the randomized number and the number we entered. That's pretty interesting too, I would say. Before we filled a number container with a random value, we could have said generate a random value and then say put that into the number container. That's kind of the way I'm approaching it here. Is first I'm generating the information, and then I can say store that info in the container for comparisons. So this one step I kind of just decomposed into two steps. I could have written this similarly in two steps. But what we're doing is the same thing. We're filling a container with a value that we derive somehow. I'm just kind of separating that for, that's just the way it came to me. So we've completed this part of step 4. We've compared the two numbers. Now we need to output something. We need to output true or false. That's the same or different is how we could read it. True or false, that's two different outputs that we want to output one or the other. Same or different, those are two different things. Comparisons, depending on the type of comparison, if you're just doing a strict same or different comparison, that's two different things. And that's, I guess, one of the ways that we can read into how a comparison, information containing a comparison, is different than a number. There's a lot of numbers. There's only two ways to say if something is same or different. So how will we display that? Again, that might be different depending on our programming language or environment, but we are going to display that information. We're going to, again, for some of the most common output method, in fact, I'll just copy that, we're going to display the, let's say, meaning. Numbers have values, comparisons have meanings. So we're going to display the meaning of the contained comparison. And I would say that that's pretty good for step 4. And let's move on to step 5. But before I do that, let's just notice we went from 4 lines to 11 lines from there to there. So if we turned 4 into 11, that means there was a lot of hidden language, a lot of ambiguous meaning in each one of these lines that we kind of spread out through each of these steps. These are certainly they have some ambiguity too, on purpose and on accident. We're developing our skill with pseudocode as well as we go through this process. But what we did do is we spread out ambiguity over more area, so to speak. Isn't that kind of interesting? I think that's an important concept to keep in mind, is we spread something out. Whenever you spread something out or focus something to as much of a point as you can, you're doing something interesting there. And we'll leave that discussion for another time, but notice that for now. All right, time for step 5, repeat. This is a bit of a weird one, of course. Patterns repeat. A lot of patterns repeat. Some don't. A lot do. It's a big classification of patterns, is that they repeat distinct steps over and over and over again. As programming languages are just a language to describe patterns, there's very likely going to be some fundamental way to repeat steps. Just like there's some fundamental way to hold information or to create information, there's going to most likely be a way to have a pattern repeat. Now, we could just, whatever the pattern is for these, we could just copy it a whole bunch of times, however many times we think that will be necessary for the program to run. But we could also just refer to that happening without actually duplicating it. We can refer to it duplicating for it to somehow start again at the beginning with code. So whatever that process is in a language, we'll do that. But this is very ambiguous language. It's kind of noted that this line 2 and this line 5 only translated into one line. We didn't really spread out the ambiguity other than just giving it more words, which can also increase ambiguity. Those are going to be interesting steps, I think, for sure. It might just be that this could have been one step and then we would have spread it out, and we already kind of broke down the ambiguity here. I don't know. I don't quite know about that yet, but what I do know is that these are going to be interesting steps nonetheless, especially 5. We will see some, as far as I know from the programming languages I've learned, some of the basic constructs in this, creating a variable, using if statements down here, displaying the meaning. We're going to be using an if statement there, using booleans, using while loops or for loops. Those are some of the first things I've learned when I went into a programming class or when I've tried to learn a programming language online. It's good that we are going to hit on quite a few of those ideas through this simple program. And this is half of a page. This didn't take too long to make. It's not going to take too long to program, hopefully. This is the process of pseudocode. Whether we did a good job, whether we need to go back and do more, we got to see what pseudocode is like, what it's like to make it. And now that we have it, well, we can do interesting things with it. I think that's enough for right now. We'll come back to this and use this, and I'll see you then.